In the vast, silent theater of space, we have become accustomed to the quiet rhythm of discovery. We track asteroids, we chart the course of comets, and we watch the slow, predictable dance of the planets. Most of it is routine. Comfortably, reassuringly routine. But on June 18, 2025, that rhythm was broken. The broadcast of a lifetime was interrupted, and in the silence that followed, a single, terrifying question began to form. The subject was 3I/ATLAS, our third confirmed interstellar visitor. An object from beyond our solar system, briefly passing through our neighborhood before continuing its journey into the void. NASA had a live feed trained on it, a public window for the world to watch this rare traveler. The time was 3:17 UTC. On screens around the globe, the comet was a familiar, smudgy dot of light against the black. And then it wasn't. In an instant, every public channel, every data stream simply cut to black, a clean, sudden, and total signal loss. But in the fractions of a second before the darkness, something slipped through. A single, final frame of data was captured by independent archivists. A frame that showed something that didn't look like a comet at all. A frame that might change our understanding of the universe. Today, we are going to walk through exactly what happened on that day. We will examine every piece of the puzzle, the strange nature of the object itself, the impossible image that appeared, and the deeply suspicious blackout that followed. We will lay out the facts, step by step, and explore whether the data truly point to what some now believe, something engineered. Before the incident, 3I/ATLAS was already a source of intense scientific interest. It was, in a word, an outlier. Every new piece of data only deepened the mystery. First, the basic facts. Comets from our own solar system follow predictable, elliptical orbits around the Sun. They are members of our celestial family. 3I/ATLAS was different. Its trajectory was hyperbolic, a perfect open curve. This wasn't an orbit, it was a flyby. It was moving at a staggering 130,000 miles per hour, a velocity so high that it could only be achieved by an object falling in from interstellar space. It was not bound by our Sun's gravity. It was just passing through. Then came the composition. As comets approach the Sun, they heat up, and ice sublimates into gas, forming a cloud around the nucleus called a coma. By analyzing the light from this coma, a process called spectroscopy, we can determine its chemical makeup. The coma of 3I/ATLAS was found to be 20 times richer in carbon dioxide than any comet ever recorded from our own system. This unusual chemistry suggested it formed in a radically different environment than our own solar system provides. But the strangest anomaly was the glow. Weeks before the blackout, astronomers noted a faint, persistent glow on the comet's night side, the side facing away from the Sun, where no sunlight should be able to reach. An object in space doesn't simply produce its own light. This defied simple explanation. Was it an unusual chemical reaction in the coma? An unknown form of energy release? Routine spectroscopy flagged these anomalies, but they remained deep, unanswered questions. This object was already rewriting the book on comets before the real drama even began. At 3:17 and 12 seconds UTC, the downlink from the tracking satellite produced the image that would change everything. For a fleeting moment, the live feed showed a razor-straight glint of light, 37 pixels long, cutting directly across the comet's nucleus. To a casual observer, it might have looked like a stray pixel, a visual error. But to the automated systems and trained astronomers watching, it was an impossibility. Edge detection algorithms, software designed to identify shapes and structures in image data, flagged it instantly. For those unfamiliar, a hash is a cryptographic fingerprint. If even a single byte of data is different, the hash will be completely different. The fact that all three archives, on 3 different continents, produced identical hashes is irrefutable proof. There was no tampering. There was no compression artifact. There was no man-in-the-middle attack. The data was pure. The same impossible straight edge appeared in every single copy. When faced with an extraordinary piece of data, the scientific method demands that we first exhaust all ordinary explanations. And so, the global astronomy community began to troubleshoot. First, could it be a cosmic ray hit? Our planet is constantly bombarded by high-energy particles from deep space. When one of these particles strikes a camera sensor, it can overload a pixel, creating a bright spot in an image. But a cosmic ray hit is a one-off event. It appears in a single frame and then it's gone. The archived data buffer told a different story. The glint didn't just appear in one frame. It persisted, stable and unchanged, across 4 consecutive frames, each captured exactly 200 milliseconds apart. The shape was static, held in place. This was not a random particle strike. Next, could it be a background star? Perhaps a distant star just happened to align perfectly with the comet for a moment, creating the illusion of a feature on its surface. This is where the science of astrometry comes in. By precisely mapping the object's position against the fixed field of background stars, astronomers can distinguish between foreground and background objects. Astrometry ruled out any known star or celestial object in that precise location. The glint was moving with 3I/ATLAS. It was physically associated with it. Finally, the most common explanation for strange images: a camera glitch. Digital sensors are complex, and they can fail in predictable ways. Dead pixels, faulty columns, electronic noise, they all create patterns. But those patterns have signatures. They don't manifest as a micrometer-perfect geometric line, 3 kilometers in length, that maintains its integrity as the object it's on rotates and moves through space. The geometry was too perfect, the scale too vast. The glitch hypothesis was discarded. So, after eliminating the most likely culprits, we are left staring at 2 remaining live possibilities. 2 explanations for what the feed captured. 1. An uncanny, astronomically improbable natural alignment of crystalline ice shards that happen to form a perfectly straight line and catch the sun's light in just the right way. A fluke of nature. 2. The first resolved piece of an artificial structure on an interstellar traveler, a piece of technology. As the scientific community was reeling from this data, NASA's response arrived. The next morning, an official statement was released. It read, "Routine maintenance on the Deep Space Network caused a temporary loss of signal from the observation platform. No data were compromised. Routine maintenance, a simple, clean, bureaucratic explanation. But the evidence on the public record told a very different story. The checksums of the archived data before and after the 9-second gap were a red flag. 3 petabytes of infrared data from the moments leading up to the blackout were missing. They hadn't just been lost or corrupted. They had been overwritten with zeros. This is not what happens during a simple signal loss. This is what happens during a deliberate forensic wipe. It takes processing power and intent to zero out data. You do it when you don't just want to delete something, but you want to ensure no one can ever recover what was there." Then came the leak. An internal chat log from NASA's Jet Propulsion Laboratory, scrubbed from the official servers but archived by one of our own subscribers before it could be erased, showed a frantic, clear-as-day exchange. A message, time-stamped just seconds before the public feed was cut, read in all caps, "Off-nominal artifact detected. Suspend public forward link." Let's break that down. Off-nominal is NASA jargon for not normal. It means a system is operating outside of its expected parameters. An artifact has been detected that shouldn't be there, and the command that follows is unequivocal. Suspend public forward link. Cut the feed that the public sees. This wasn't routine maintenance. This was a direct, panicked response to the object on the screen. What could trigger such a hard stop? Such a drastic and suspicious reaction? We can imagine 3 scenarios. Option A, a mundane but catastrophic encoder fault. It's possible that a piece of hardware failed in such a specific way that it only erased the video data from the comet's observation window. But the odds of a hardware failure being so precise, coupled with the timing and the leaked chat log, feel vanishingly thin. Option B, an automated filtering system. It's plausible that public streams like this one are run through automated gatekeepers, AI systems designed to flag and filter out anomalies that exceed certain confidence thresholds. Perhaps the razor-straight glint was so far outside the definition of comet that the system automatically triggered a blackout to prevent unverified and potentially panic-inducing data from going public. This is a more plausible, less conspiratorial theory. Option C. Deliberate human intervention. Someone in a control room saw the glint, understood its profound implications, and made the call to pull the plug. They ordered the feed cut, and the data wiped because the system was seeing something it couldn't classify, and they couldn't risk the world seeing it in real time. This explanation is uncomfortable, yet it is the one most consistent with both the leaked chat log and the forensic evidence of the zeroed-out data. For a time, the debate raged between these possibilities. But then, researchers analyzing the comet's flight path over a longer period discovered one more piece to the puzzle, one more off-nominal behavior. Between July 15th and August 1st, long before the blackout, the object's velocity vector, its direction and speed, shifted by a tiny but clearly measurable 3.4 millimeters per second. Now, a comet's path can change. As it nears the sun, ice turns to gas and erupts in jets from the nucleus. This outgassing acts like a small natural thruster, producing a random jitter in its trajectory. But this process is always accompanied by a visible increase in the coma's brightness and size. More thrust means more gas, which means a brighter coma. The course correction of 3I/ATLAS had no corresponding increase in coma brightness. It was a silent, invisible change of course. This was not the random jitter of natural outgassing. This was a single millimeter-perfect correction performed in the deep cold of space, 40 astronomical units from the sun. It was the kind of maneuver we see every day in our own space program. It's the behavior we meticulously program into billion-dollar probes for station keeping and trajectory adjustments. It was the signature of a controlled, powered event. Put the pieces together. The glint, a 3-kilometer line of highly reflective material. The blackout, a panicked and poorly concealed effort to hide data. And the mid-course tweak, a subtle but unmistakable sign of propulsion. When you place all three of these facts side by side, the null hypothesis, the idea that it's just a weird comet, starts straining under its own weight. So, where do we go from here? This is not a closed case. This is an active investigation, and you can be a part of it. The FITS files, the raw scientific-grade images, are public. Anyone can download them. You can load them into a program like Astropy, align the images on the background field stars, and subtract the nightly stacks to see if that razor-straight edge drifts against the background. If it moves perfectly with the comet's nucleus, we are seeing a real, physical surface feature. If it doesn't, we have falsified the artifact, and it's some other optical phenomenon. Science wins either way, but only if we keep looking. The clock is ticking. 3I/ATLAS reaches perihelion, its closest approach to our sun, on October 30th. After that, it will slingshot around our star and begin its long journey back to the dark between the stars, lost to us forever. But we have one more chance. The James Webb Space Telescope has a discretionary 12-hour block of observation time scheduled for September. Its powerful infrared instruments will be able to see this object in unprecedented detail. If that infrared light curve shows evidence of seams or panels or unnatural heat signatures, this debate may very well come to an end. And if, during that observation slot, the public feed drops again, well, even the most dedicated skeptics may start asking louder questions. What is your hypothesis? Drop it in the comments below. A cosmic glitch, an impossible geometry of ice, or a piece of star-hopping technology? Share this with the friend who still thinks we're alone in the universe. And be sure to hit that subscribe button, because the moment those Webb images land, we will be here to walk through every single megapixel together.